Dear students, today I am going to explain you about prochirality in this class. It is part of principles of asymmetric synthesis unit. Okay, so as I taught you in the previous classes of different terminologies in asymmetric synthesis, this one prochirality. In prochirality, there are two words. Okay, you can separate them: pro and chirality. Pro and chirality. Chirality. Pro means the before step. Okay. Chirality means you know about chirality. Chiral and chirality. You need to understand these words. Chiral and chirality. What is chiral? What is chiral molecule and what is chirality? Okay. I'll give you one example, the best example. With this example, it is easy for you to understand about chiral and chirality, right? So this is the molecule. This molecule in this central carbon atom attached to 4 different groups or atoms. Okay, 4 different groups or atoms in this molecule. Therefore, this molecule does not have any symmetry element in that, like plane of symmetry, center of symmetry, alternative axis of symmetry. Okay, that's why it is called asymmetric molecule. Asymmetric means absence of symmetry elements in that molecule. Okay, what are the symmetry elements? Plane of symmetry, center of symmetry, alternate axis of symmetry, like this, etc. These kind of symmetry elements absent when that central carbon or that central atom attached to 4 different groups or atoms in that molecule. So therefore this molecule considered as chiral molecule. Okay, this molecule is considered as chiral molecule. Okay, and this property is known as chirality. This property is known as chirality, right? So chirality is a property. With that property, that molecule is able to rotate plane polarized light. Therefore it is optically active. So if that molecule optically active, that means it is biologically active. It is biologically active. So therefore this property is known as chirality. Okay, so prochirality means before that molecule converted into chiral, that previous molecule is known as prochiral molecule, and that previous molecule can be, that property exhibits the property prochirality. Do you understand what I'm saying, right? So first of all, chiral and chirality. If a molecule, in a molecule, if the central atom or carbon attached to 4 different atoms or groups in that molecule is considered as chiral molecule. It is nothing but asymmetric molecule. Okay, in another way, that molecule does not have any symmetry elements in it, like plane of symmetry, center of symmetry, alternate axis of symmetry. That's why it has a beautiful property, that is nothing but chirality. With that property, it can rotate plane polarized light towards right or left. That means it is optically active. If it is optically active, that molecule considered as biologically active molecule. So we need biologically active molecules in chemistry, especially in the field of medicine, right? So majority of the drugs are optically or biologically active. The reason why they are biologically active because of chirality. Okay, So therefore, it is very important to understand about chirality. Okay. So prochirality. Prochirality means the molecule in that step, prochiral molecule converted to chiral molecule by using some stereoheterotopic units. That property is called prochirality. Okay, prochirality. As I mentioned one example, in Central University, there is a vice chancellor in that university. Also, there are some pro vice chancellors. What is the meaning of pro vice chancellors? Pro vice chancellors means in the next level they will become vice chancellors. Okay, so before they become vice chancellor, they can be considered as pro vice chancellor. Similarly, before that molecule converted to chiral, that molecule considered as prochiral molecule, and that property is known as prochirality. Okay, so this is the example I want to give you. Okay, Cl, Br and H and H. If you substitute hydrogen, because there are two hydrogens, similar atoms, so I can distinguish by Ha and Hb. Okay, so if you substitute Hb with fluorine, you will get a molecule like this: chlorine, bromine, fluorine and hydrogen. So another one is chlorine, bromine, fluorine and hydrogen. Okay, consider this is an example reaction. So this is the molecule converted to chiral stereoisomers. These two isomers are chiral stereoisomers. Chiral stereoisomers. Stereoisomers. Why I am saying chiral stereoisomers? Because in the central carbon atom surrounded by 4 different groups or atoms in that molecule. Okay, these two are asymmetric stereoisomers, chiral stereoisomers. If a carbon attached to 4 different groups or atoms, that carbon is considered as chiral carbon, and therefore these two are chiral stereoisomers. Stereoisomers because these two are enantiomers. These two are enantiomers. Okay, these two are enantiomers. Okay, here Ha replaced with fluorine. Okay, this molecule considered as prochiral molecule. Prochiral molecule. These two are chiral stereoisomers, whereas this starting material is considered as prochiral molecule. This center is considered as prochiral center. Okay, what about this? These two are chiral centers. Chiral centers. This is also chiral center. Chiral center. Okay, now with this example, it is very clear to understand that in this reaction, this molecule converted to chiral molecule. This is a chiral molecule. This is a chiral molecule. There is no chirality because there are these two hydrogens attached to this carbon. Okay, so when I said about chiral molecule, in that molecule, that carbon, that central atom attached to are surrounded by 4 different atoms or groups, then only it can be considered as chiral. Therefore, it does not have any symmetry element in that structure. Therefore, it is optically active. If it is optically active, that means it is biologically active. Okay, so this is not chiral molecule, but it can be considered as prochiral molecule. Prochiral means in the one step it becomes chiral. Okay, in this step, in this reaction step, in one step, this prochiral molecule, that means achiral molecule, converted to chiral molecule. These phenomenon or this process or this property is known as prochirality. This property is known as prochirality. Prochirality means in stereochemistry an achiral molecule generates chirality by involving stereoheterotopic units in one step is known as prochirality. Okay, in this HA and HB are considered as stereoheterotopic units. Stereoheterotopic units. So I already taught about you stereoheterotopic units. Okay, homotopic unit, heterotopic units. In heterotopic units, stereoheterotopic units and structurally heterotopic units. Anisotropic units, diastereotopic units. All those terminologies I explained you in previous class. All right. So here, this is an achiral molecule. Achiral molecule, the property of an achiral molecule generates chirality by involving stereoheterotopic units HA and HB in one step is known as prochirality. So that is the meaning of definition of prochirality. Simply, in one step, by using stereoheterotopic units in that molecule, it generates chirality or chiral stereoisomers. That is known as prochirality. Okay, so simple example, and you can understand easily about this prochirality. Okay, so what is prochiral center? Prochiral center means in a achiral molecule, the center carbon has or have stereoheterotopic units on it, and in the next step, by involving them, produces chirality or chiral stereoisomers. That center is considered as prochiral center. That center is considered as prochiral center. Okay, that prochiral center. This is the example, another example, CH3, HA and HB. So this center is considered as prochiral center. Prochiral center. This molecule is prochiral molecule, as I explained you, right? Because it have two stereoheterotopic units. These two stereoheterotopic units involved in reaction and produces two chiral stereoisomers. Okay, so in the central carbon, two heterotopic units are there. Okay, so that's why this center is known as prochiral center. This molecule is prochiral molecule. Okay, these HA and HB are considered as stereoheterotopic units. If you replace HB with hydroxyl group, you will get one chiral stereoisomer, if you replace HA with hydroxyl group, you will get another enantiomer or chiral stereoisomer. These two are chiral stereoisomers, okay, and these centers can be considered as chiral centers, whereas this center is called or considered as prochiral center. Okay, so that is about chiral centers and prochiral centers. Okay, that is about prochirality, chirality, and chiral. All this terminology is very important to understand, to know about them. Okay. So I'll give you some more examples so that you can understand. Suppose stereoheterotopic units. Stereoheterotopic units means what? In previous class I have explained about them. Stereoheterotopic units may be considered as ligands or phases. Ligands may be considered as atoms or groups. Phases may be below the plane or above the plane, or below the plane or above the plane. Okay. Stereoheterotopic units means units may be ligands or phases. Ligands may be considered as atoms or groups, whatever it may be. Phases may be below the plane or above the plane. So I'll give you one more example. This acetophenone is converted sodium borohydrate. With the help of sodium borohydrate, it produces chiral isomers, stereoisomers, hydrogen CH3 plus pH CH3 OH. These two are stereoisomers, chiral stereoisomers. They are nothing but enantiomers, right? So these two chiral stereoisomers produced by this prochiral molecule. This is prochiral molecule. Prochiral molecule. These are chiral stereoisomers. Chiral stereoisomers. These are chiral because this central carbon atom attached to 4 different groups or atoms. Therefore, it is chiral. Therefore, it is asymmetric. And here, it is not chiral because it has stereoheterotopic phases. Okay, it has stereoheterotopic phases. So this is prochiral molecule produces chiral stereoisomers in one step. So this molecule is considered as prochiral molecule, and these can be considered as chiral stereoisomers. Okay, so here phase 1 and phase 2. So sodium, this hydride comes from the front side or from F2 or from F1. So if it comes from front side, you will get one. If it comes from back side, it will get this one. Okay, the two phases, by involving these two phases, it produces chiral stereoisomers. So this property is known as prochirality. This molecule is known as prochiral molecule, and these are chiral stereoisomers, or these molecules as a property of chirality because it exhibits optically activity. That means biologically active. Okay. So I'll give you some more examples to understand clearly about these molecules. So notations notations of notations are discriminations of for stereo heterotopic units. For stereo heterotopic units, notations are discriminations for stereo heterotopic units. So if you want to give your notations or discriminations, so you need to follow Kohn-Ingold-Prelag methods or rules or guidelines to give priority in that molecule. Okay, first of all you need to identify about stereo heterotopic units in that molecule. In the second step, you need to give priorities to the priorities according to the Kohn-Ingold-Prelag method. Then, if the least priority group in vertical line, and if it is the order of priorities, if you write arrow mark, if it gives you clockwise rotation, then that notation would be pro R. If it is anti-clockwise rotation, then pro S. Okay, the notations would be like that. If the least priority group in horizontal line, and if you give priority to all the groups, and if you write the arrow mark, if that arrow mark gives you clockwise direction, that notation would be pro S. If it is gives anti-clockwise, rotation, then it gives pro R. Okay, pro R, pro S and pro R. Okay, so we will solve some examples so that you can understand how we can give notations or discriminations for stereo heterotopic units. Okay, stereo heterotopic units, because it is very important for us to understand about stereo heterotopic units. Okay, stereo heterotopic units exist in prochiral molecules. Okay, those two stereo heterotopic units can be given notations or discriminations for them based on the some rules and regulations according to Kohn-Ingold-Prelag method. So we need to give priorities to the atoms or groups which are attached to the central carbon. Okay, so according to Kohn-Ingold-Prelag method, so first we need to look at atomic number. Okay, if the higher the atomic number, then that will get high priority or first priority. Then you can, if the atomic number is same for both, then you go for atomic weight. You can consider about atomic weight. If atomic weight is also same for both, then you go for double bond or triple bond or unsaturation. If unsaturation also same for both, then you can go for the next atom. Like that you can give priority according to Kohn-Ingold-Prelag method. Okay, so I'll give you example. OH, CH3, H and H. Just for us, for our convenience, I'll put you labels HA and HB. Both are same actually. Okay. So in this, first we need to give priorities to the atoms or groups which are attached to the central carbon. Okay. Oxygen is more atomic number, therefore first priority. Carbon is second priority, gets second priority because the carbon atomic number is more than hydrogens. Okay. And the third one, if you want to decide about this atom, this is the third, and you can write arrow mark. You can connect arrow mark from first priority to third priority like this. Is this clockwise or anti-clockwise? This is anti-clockwise. Okay, this is clockwise, this is anti-clockwise. And the least priority group, is it in horizontal line or vertical line? It is in horizontal line. This is the least priority groups in horizontal line. Therefore, if it is anti-clockwise, then it is pro R. That gets pro R notation. Okay. OH, HA, HB and CH3. So this stereoheterotopic unit will find out 1, 2, 3 or 4, or you can write 3 to here. So what is the connection? Like this. Is it clockwise or anti-clockwise? So this is clockwise rotation. The least priority group in horizontal line. Therefore, this notation of HA is pro R, pro S. Okay. This is pro R, this is pro S. What is this pro R and pro S? Those are the notations or discriminations for our identification. Okay. So you need to understand. So in enantiomers or asymmetric molecules, we have configurations na, RS configurations. Okay. RS configurations comes in the chiral molecules. Okay. But pro R, pro S means they will come in prochiral molecules. Pro means in the next level, in the next step, that the configuration would be like that. That indicates. Okay. So this is pro R, right side H, pro R, left side H, pro S. So how we can identify this pro R, pro S notations or discriminations? So based on the Kohn and Gold-Pralag guidelines. So first of all, we need to identify stereoheterotopic units. These are two stereoheterotopic units, and you can give priorities based on the atomic number. Okay, oxygen gets first priority because of oxygen atomic number is more than the carbon. Then carbon gets second priority because its atomic number is more than the hydrogen. Okay, so this is the last one. Okay, so if you connect this order from lower to higher, if you get anti-clockwise rotation, then if it is in horizontal line, the least priority group, then that would be pro R. If it is clockwise rotation, but the least priority group in horizontal line, therefore it is pro S. So finally you can write like this: OH, HB, HA and CH3. This is prochiral molecule. I'll write this side. CH3, HB, HA and OH. So this is Pro R, and this is Pro S configuration, okay, and this is prochiral molecule, and this is prochiral center, okay. So these terminology you need to understand. So here this is prochiral molecule because in the next step this molecule produces chirality, chiral stereoisomers or chiral molecules by involving the stereoheterotopic units. So this HB configuration is Pro R and this HA configuration is Pro S, okay. So these Pro R, Pro S are notations, are discriminations for stereoheterotopic units to given anmat, okay. So I'll give you some more examples to understand, or to you are able to give notations or discriminations for stereoheterotopic units. So this is another example, CH3COOH and HB and HA. COOH, HB, HA, CH3. COOH, HB, HA, CH3. So these two HA and HB are stereoheterotopic units, okay. These two are stereoheterotopic units, okay. The least priority group is in horizontal because hydrogen is the least priority group, you know, it is in horizontal line. So whenever it is in horizontal line, if it is clockwise rotation, if you get clockwise rotation, then that notation would be Pro S. If it is anti-clockwise rotation, that stereoheterotopic unit notation would be Pro R, okay. Whereas if the least priority groups in vertical line, if it is clockwise it is Pro R, if it is anti-clockwise it is Pro S, okay. So based on the least priority group, whether it is in horizontal line or whether it is in vertical line, you need to observe that, okay, to decide Pro R or Pro S configurations or notations, okay, for stereoheterotopic units, right? So now which one will get the first priority? This carboxylic acid, obviously. The second one is obviously CH3. This is the third one, okay. If you connect from lower to higher number priorities, you will get this anti-clockwise rotation. That means this is Pro S, anti-clockwise Pro S. So this is, what about this 1, 2 and 3? This is clockwise rotation. Therefore, this hydrogen or this stereoheterotopic unit notation as Pro R, okay. So therefore the left side is Pro R notation. This right side is pro S notation, and this is chiral carbon, chiral center. This is prochiral molecule. Sorry, prochiral center. This is prochiral center and prochiral molecule. Okay, it's prochiral molecule and prochiral center. These two are stereoheterotopic units, and this unit pro R notation, and this stereoheterotopic unit gets pro S notation. So how we can decide pro R pro S? So based on the this Ingold Prolag method. Okay. So these are the methods or steps you need to follow to decide to give you notations or discriminations for stereoheterotopic units. Okay, so I'll give you some more examples. I'll give you some more examples. Okay, this is another example I want to explain you so that you can understand, you can become expert to assign pro S for pro R configurations. Okay, so here which one is highest priority group among these? It's the bromine, obviously, because its atomic number is more than any other, more than oxygen and carbon. Okay, so if you want here in the first step you need to identify stereoheterotopic units in that molecule. Stereoheterotopic units should be similar and two. Okay, in this which are the two groups similar? Bromine and bromine. Okay, so therefore bromines are stereoheterotopic units in this. So if you want to assign these notations or discriminations, suppose if you want to assign this bromine, then it gets first priority. About second priority oxygen, third priority is carbon. Okay, so you can write the arrow mark like this. So it is anti-clockwise rotation, anti-clockwise rotation. And also you need to observe the least priority group. Is it in horizontal line or vertical line? Okay, in this case it is, which is the least priority group? This is CS3 because it gets third priority, least priority. Okay, 1 2 3, this is the least priority group which exists in vertical line. If the least priority group exists in vertical line, it is, if clockwise rotation then pro R, if anti-clockwise rotation it pro S. Here it is anti-clockwise rotation, therefore this is pro R, anti-clockwise. Anti-clockwise, yes, because the least priority group in horizontal vertical position. Suppose that side, this side bromine will C, OH CH3. Okay, this bromine stereoheterotopic unit as we will assign for this bromine first priority, second priority and third priority. If you write arrow mark connecting priorities, so this will get clockwise rotation. Clockwise rotation. The least priority group is in vertical line. If it is clockwise rotation, that stereoheterotopic unit gets pro R. pro R notation. Okay. If it is anti-clockwise, pro S. So that means bromine CH3 OH. This bromine is pro R, pro S. This bromine is pro R, and this is prochiral center. This is prochiral center. This molecule is prochiral molecule. Prochiral molecule. So this prochiral molecule is able to produce chiral stereoisomers in one step of reaction. So therefore, this property is known as prochirality. That property is known as prochirality. Okay. So I hope you understand how to give priorities and how to assign pro S and pro R notations or discriminations for stereoheterotopic units. Okay. Stereoheterotopic units. I'll give you one more example. CH3 OH Br. So this is another example I want to I would like to how to assign for this molecule. First you need to identify what are the two stereoheterotopic units in that prochiral molecule. Obviously here CH3 and CH3. Okay, because they are two similar groups. Okay, first priority this one, second priority this one, and third priority this one. Okay, if you rotate like this is clockwise rotation. It's a clockwise rotation. The least priority group is in horizontal line. The least priority group is in horizontal line. Therefore, this is the least priority group which is in horizontal line. Therefore, this notation is pro S. Pro S. So what about this CH3? Suppose 1, 2 and 3. Same. Clockwise rotation only. But the least priority group is in vertical line. In this case horizontal line, therefore S. In this case it is vertical line, therefore pro R. Pro R notation for this. Okay. So if this kind of molecules is there, this is pro S, this is pro R. So that's how we have to give priorities or discriminations or notations. Like, I hope you understand how to give notations or and so molecules with more than one prochiral center. I'll give you one example for that. Molecule with more than one prochiral center. This is the COH and COH, H and H, OH and H, H and H. So this is the molecule This is the molecule which has three chiral centers. So one chiral center and two prochiral center. This is one prochiral center and this is one prochiral center. Okay, HA and HB and HA and HB. So this molecule has two prochiral centers. So if you assign notations for this, it will become pro R. This will be pro S notation. Okay, and it is reverse, pro S, this is pro R for this bottom prochiral center. Okay, so this molecule with more than one prochiral centers, that means in these two prochiral centers are there. Okay, so one is above, another one is below. So how to assign the notations or discrimination? As I told you previously, you need to first identify two stereoheterotopic units, then you can give priorities to four groups, and you can check the least priority group whether it is in horizontal line or the vertical line. If it is vertical line, the least priority group, if it is clockwise rotation, it is pro R. If it is anti-clockwise rotation, it is pro S. If the least priority group in horizontal line, if it is clockwise, then it is pro S. If it is anti-clockwise, it is pro R. So that you need to take care to assign notations or discriminations for stereoheterotopic units. Okay. So lastly, notations for stereoheterotopic bases. Notations for stereoheterotopic phases. Stereoheterotopic phases. So I'll give you example. pH estophenol. Okay, estophenol. Similarly, as I told you previously, so you need to give priorities based on the atomic number or atomic weight or the unsaturation or the next atom. Okay, so if it is clockwise priority order, then that phase is rephase. Clockwise priority order, then that is rephase, RE. We can represent as RE. Rectus. RE means rectus. Rectus means clockwise. Okay. If you give priorities, if the priority order is clockwise, then that notation would be RE, which is nothing but rectus, which means clockwise. Okay, rectus. So first we'll give priorities. This one, oxygen gets first priority because its atomic number more than the carbon. Phenyl group gets second priority because it has unsaturation and bulky group compared to CH3. CH3 is the last priority group. Then you can connect priority order from 1 to 2 and 3. So it is anti-clockwise rotation. Okay, anti-clockwise rotation. Anti-clockwise rotation means psi, sin star. That means anti-clockwise. Anti-clockwise. So this is the psi phase. Psi phase means this is the front, psi front phase. Okay, so first you need to give priorities. Oxygen gets first priority, phenyl group gets second priority, and methyl group gets third priority. So if you connect this priority order with an arrow mark, if you get anti-clockwise rotation, then that front is psi phase, psi, SI. If it is anti-clockwise rotation, that is rephase, RE, rectus, that means clockwise. Okay. Suppose I'll write this molecule as this pH CH3. First priority, second priority, and third priority. So that means you can connect like this. So that means this is a rephase, this is the back side. Okay, rephase. Rephase is front and psi phase is back, because we turn that molecule from this place to like this. So that psi phase will go back, therefore rephase will come front. Okay, so that's why if you reverse this molecule, the notations or discriminations of this re and psi notations will be changed. Okay, so I'll give you some more examples on this. CH3 OH. Suppose this is the molecule, so you need to give notation for this. Which one is more priority in this? Oxygen, this hydroxyl group, and this 3. So this is the clockwise rotation. Re is front. Okay, if you reverse that one, CH3, 1, 2, 3, anti-clockwise rotation. This is psi phase, psi front. So back is re. Okay, like this you need to give notations. So what about this? So this is first priority, this is second priority, this is third priority. Anti-clockwise, psi front phase, psi front phase. So I'll give you one more example. So for this center, Prochiral center, 1, 2, and 3. Clockwise, reef. Okay, here 1, 2, 3. This is anti-clockwise surface. Okay, so these are the things you need to understand to give notations or discriminations for prochiral molecules or uh, prochirality molecules. Okay, I hope you understand about prochirality. Okay, first I defined what is prochirality. So if you want to define prochirality, you need to know about what is chirality. If you want to know about chirality, you need to know about chiral. What is chiral molecule? What is chiral? All those things I explained. Okay. Prochirality means in stereochemistry, an achiral molecule. The property of an achiral molecule generates chirality by involving stereoheterotopic units in one step is known as prochirality. Okay, so prochiral means in that prochiral molecule it have two stereoheterotopic units which can produce two chiral stereoisomers. Okay, so in the next step reaction. Okay, so that is about prochirality. So in prochirality, it is required to give notations or discriminations for stereoheterotopic units. That means pro R, pro S. Pro R, pro S means first you need to identify in that prochiral molecule what are the stereoheterotopic units. Then you can give priorities based on the atomic number or atomic weight or according to Kohn-Ingold-Prolog method. Okay, so and if it is the least priority group is in vertical line, if it is clockwise, then pro R. If the least priority group is in horizontal line, if it is clockwise, then it is pro S. If it is anti-clockwise, it is pro R. Like that you can determine or you can assign pro R, pro S to the prochiral molecules. And lastly, I explained about uh, prochiral phases, right? So you need to give uh, priorities, and you can write down the clockwise. You can write down the arrow mark from connecting from first to last priority groups. Okay, if it is clockwise rotation, then it is RE phase. Okay, RE, rectus or clockwise. If it is anti-clockwise rotation, it is SI, sign star, anti-clockwise rotation. Okay, so that's how you can assign RE and SI notations or discriminations for stereoheterotopic phases. Stereoheterotopic phases means so that molecule has two phases, F1 and F2, which are not equal, which are different. Okay, so those two phases can generate chiral stereoisomers in the next step reaction. Therefore, it is very important to give these kind of notations or discriminations for stereoheterotopic units. Stereoheterotopic units may be atoms, ligands or phases. Ligands may be atoms or groups, or phases may be above the plane or below the plane. Okay, so these are the things you need to understand. Then you will be able to assign all these notations or configurations easily. Even you will get you will get questions in CSR also. Therefore, practice more examples. So if you don't understand, let me know so that I can explain you. Okay, bye.